Hi class, this week we're going to be talking about reliability and validity. These are the specific learning objectives for this week, and you're welcome to read them on your own. In psychology, we test hypotheses, and there are lots of different ways that you can do this. This refers to methods. So let's say you want to study happiness. You could ask someone verbally via an interview. You could observe their behaviors. You could ask them how to fill out a survey. You could ask them to fill out a survey or a questionnaire. You could maybe also ask their friends. Or maybe if you had the resources, you could run an fMRI on their brain and check to see if part of the brain that's responsible for emotions lights up or not. You could do lots of different things to be able to measure whether someone's happy or not. All of these are called measures because you are measuring the hypothesis. Sometimes measures are also referred to as instruments, just an FYI. So if you hear measures, instruments, it's the same thing. So when we're choosing the measure, we need to think about our resources. So do we have an access to an fMRI, for example? But something we also need to think about when we're choosing the measures is we need to think about reliability and validity. So before we get into the more details of reliability and validity, let's just take it back a minute and let's think about it for a second. What does it mean to say that someone is reliable? What does it mean to say that's a valid point? We use these terms all the time, reliable and valid. So think for a second about what those two words mean. If I were to ask you, what does it mean to say someone is reliable, what would you say? Now, what does it mean to say that's a valid point? What would you say? Okay, so what I would say is if someone asked me, what does it mean to say someone's reliable? I would say it means to say that they are consistent. What does it mean that's a valid point? It means to say that is an accurate point. So now that we've talked about what reliability and validity mean in basic terms, let's talk a little bit more about them. So let's focus on reliability first. So let's talk about another everyday explanation. So Dr. Giddens is reliable because she always posts the module's material on Monday morning of each week. That's an example of how I could be reliable. Professor Giddens is not reliable because although the class is supposed to be posted for the week each Monday morning, sometimes she doesn't post it until Monday afternoon or even on Tuesdays. That would be when I'm not being reliable. So in this example, the measure of reliability for Dr. Giddens is her timeliness because you are measuring her based off whether she posts the module's materials on Monday morning of each week. So let's think about a hypothesis you'd want to test and then decide the measure. So I want to test someone's IQ. I've decided that I'm going to give them an IQ test as my measure. On Monday, they scored high. On Tuesday, they scored high again with that same test. This would be a reliable test. But let's say that Monday they scored high and Tuesday they scored low. This would be an unreliable test. It's giving unreliable results. So when you're trying to measure something, you want to get true information to the best of your ability. That's your goal as a researcher. Thus, you want to choose a measure that will help you get to the truest information. However, how do you know what is true? The best you can do is measure and then hope the information is true. So let's go back to that example. If you were measuring someone's happiness and you decide that you want to do a survey, you put out the survey and you hope that you're going to get the truest information. You're not always going to get completely true information, but as a researcher, you want to do the most that you can and the best that you can to choose a measure that's going to get you true information. So the best you could do is measure and hope the information is true. The measured score is called the observed score, and the truth is called the true score. The true score is hypothetical though, because you can never be 100% sure that what you've measured is true. Because you can't be 100% sure, you're always going to be having some measurement error. So an unreliable measure will have lots and lots of measurement error. You want to choose a reliable measure with less measurement error. So you want observed score and true score to be equal, but that's not possible. So you're always going to have true score plus measurement error, and that's going to be what your observed score is. So there's lots of different types of reliability, and we're going to go over some different ones that you can use in research studies to show that you are using reliable measures and producing reliable results. So the first one we're going to talk about is test-retest reliability. So this is assessed by measuring the same individuals with one test at 2 points in time and comparing the results. If the test gives the same results each time, it's reliable. So maybe use the measure on Monday, use it again on Tuesday at a different time, and then compare the results. If the test gives the same, it's reliable. Another one is called alternate or parallel forms of reliability, and this uses two forms, but very similar forms of the same test for testing instead of repeating the same tests. So this avoids problems with participants maybe remembering and then just repeating earlier responses, because in test-retest reliability, what you would be doing is giving the same test over and over again with the same individuals. Alternate and parallel forms reliability ensures that there hasn't been any memorization that has potentially happened. Another type of reliability is called internal consistency reliability, and this assesses the reliability using responses at only one point in time. So let's say, for example, you have a 100-question test, and you ask the same types of questions in the test multiple times to see if they answered it the same. So for example, let's say you are interested in measuring whether someone is outgoing. You could ask them several questions similar to, do you enjoy lively parties, and see if they get answered similarly. This is beneficial because you don't have to get the participants together more than once. So in test-retest and alternate parallel forms reliability, you would have to get the same participants together over and over again. But with internal consistency reliability, instead what you're doing is you're building the reliability into the test itself. That way you can ask multiple questions, but in similar ways, so that way you only have to see the participant one time. Another type is called split half reliability. So this splits the test or the measure in two and compares the total score on one half of the test with the total score on the other half of the test. And this is another way of showing reliability in which you don't have to get the participants together more than once. And some other ways to show reliability in research, you can have inter-rater reliability. So this is when two researchers use the measure on the same research question and they'll give similar scores. So for example, let's say there's two researchers and they're measuring whether a child is aggressive, and on the measure that you've chosen to use, they rate the child the exact same. That would be inter-rater reliability. Intra-rater reliability is similar, but this is only when one researcher uses the same measure on the same research question at different times and gives similar scores. For example, one researcher is measuring whether a child is aggressive, and they rate the child the same but at different times. So maybe on a Monday and then on a Tuesday. So the measure is working regardless of the time that it's taking. So how do you know if a measure is reliable? Oftentimes you run what's called a correlation coefficient statistics. And so this measures whether there's a relationship between the variables. So we went through this last week. These were different types of relationships that you might see between variables. And the correlation coefficient ranges from 0 to +1 and 0 to -1. And the closer that you are to +1 or -1, the stronger the correlation there is. And we'll show that on a graph in just a second on the next slide. So to be able to get this correlation coefficient number, first you want to graph the data on a scatter plot. So one of these ways, you graph the data. So there'd be lots of dots around here. And then you draw the relationship or draw the line that best fits the data. And then you could run the correlation number with software or even with Excel. And that would give you the result in terms of how positive or how negative or how curvilinear or whether there's any relationship at all. So here's some examples. So here's a positive relationship, and when they ran the correlation coefficient, it's a 0.7. So that's getting close to 1. It's not extremely, it's not positively, extremely positively strong, but it's still pretty strong. And how you can also see it is you can see all these dots right here on the graph are pretty close to this line as compared to here. So here there's still a positive relationship happening, but the scatter plot dots are not as tight together with the line. So there's still a positive relationship, but it's not highly correlated. And then here there's no relationship. So there's not positive or negative, and that's equal to 0. That's the correlation coefficient. Here's a negative relationship that's relatively strong. It's close to -1. Here's a -0.3, which is kind of a semi-loose negative relationship. And then again, here's a 0, which there's no relationship here. So if you need more help, this is another YouTube video that you can watch on your own that explains what the correlation coefficient is and how that relates to reliability. But the idea is that with your measures, you would want them to be highly correlated. So you'd want something closer to here in order to say that your measure and the data that you're getting from your measure is reliable. So reliability is important, but so is accuracy or validity. So let's move on to validity now. It's important to know that a measure can be highly reliable, but not accurate or not valid. So reliability tells us whether the measure is consistent. It doesn't tell us whether the measure is any good at measuring what we want it to measure. So for example, suppose your bathroom scale was reset to read 10 pounds lighter. The weight it reads will be reliable, the same every time you step on it, but it will not be valid since it's no longer reading your actual weight correctly. So that's why validity is important as well, and that's why reliability and validity are taught together. So let's talk about validity now. Let's start with an everyday explanation. Professor Giddens is valid because she posts lectures on research methods, and this is a research methods course. Professor Giddens is not valid because she posts lectures on US history, and this is a research methods course. So here I could be reliable. So let's say that here I could be reliable. Let's say that I post lectures on US history every single week, but it's not valid because this is a research methods course. So that's another example when you could have reliability but not validity. Let's think about a hypothesis you'd want to test and decide the measure. So I want to test someone's level of depression. I have decided I will give them a depression test as my measure. I ask them questions about whether they have lost interest in what they used to find fun, if they have problems sleeping, if they have gained or lost weight, if they have less energy, and if they have considered suicide. This would be a valid test because all of these things add up to the fact that someone can be depressed. But let's say I ask them about their race or maybe about their political leanings. This would be an invalid test because these are not related to depression. So this is the exact same slide as earlier before. Same with reliability. You have an observed score and a true score and measurement error. So you want to try to choose a measure that will minimize measurement error. That way your observed score can be as true of a reflection of the true score as possible. So what we're talking about today, all of the validity measures we're going to be talking about are construct validity measures. A measure has construct validity if it actually measures what it is intended to measure. So for example, a test about depression measures depression. So what is a construct? A construct, for example, in this case, is depression, and then the measure is the test. But a construct, by definition, is an idea that can't be directly measured itself. So let's watch a video together to talk a little bit more about what a construct is, because we use them all the time in psychology and the social sciences.
In this video, I want to talk about the idea of a construct in psychology. This is one of those things where when you see the definitions, sometimes they can be extremely complicated sounding and confusing, and really the concept is pretty simple, and I'm going to try to approach it in a very simple way. So first of all, let's talk about something that's not a construct. Let's get a little context here. So the big picture is this has to do with variables, and it has to do with measuring and defining variables and understanding variables. Let's talk about a variable that is not a construct. So height would be an example of a pretty simple variable. It doesn't get much simpler than something like height. And I say it's simple because height is something that is, we might say, directly observable. We can directly look and literally see how tall something is. So if we have a person in our experiment, in our study, whatever it might be, and we're wanting to know something about their height. Maybe we're studying something to do with growth hormone, and we want to know how tall different people in our study are. So we can take a tape measure and put it up next to the person. And we can literally see how tall they are. So this is a directly observable variable. But in many areas of science, we have variables that are not simple at all. And by not simple, I mean we can't directly look and see them, or we can't see certain aspects or elements or parts of them. So a good example of this would be something like gravity. We know that there is something that makes objects fall to the ground, and you think, oh, that's gravity. We can directly see gravity, but we can't directly see it. We see the effects that it's having. We see that when something goes up, then it falls back down. We see that the planets orbit the sun in a certain way. We say these things are caused by gravity, but gravity itself is not directly observable. So gravity is what we would consider a construct. And the definition that I'll give you for construct, I'm going to try to keep it very simple, is it's a variable. It's a variable that cannot be directly observed. And I would say that if you want to really get technically correct about this, we could talk about that you might be able to observe some parts of the variable or some aspects of it. You can certainly observe the effects that the variable has. Otherwise, we wouldn't know it was there. But we can't directly observe it. So we know there's something out there that causes, when you throw something up in the air, it causes that thing to fall back down to the ground. We know there's something out there that causes satellites to orbit the Earth and the planets to orbit the sun. We know there's something out there that's causing these things. We know many of its characteristics. We know the effects that it has, but we don't actually know what it is exactly. And we don't know all of its characteristics or all of its properties. And so far, we haven't figured out a way to directly observe all of those characteristics. Although physicists are always working on coming up with new ways to do that. So the idea is we have this knowledge of the effects that something is having, or some of the characteristics that it has, but we don't know exactly what it is. But we decide, well, there's got to be something out there. There's got to be something out there that's causing this. There's some variable that we can't directly get to, but we're going to go ahead and label it. In this case, we're going to call it gravity. We're going to try to describe it as best we can, and we're going to try to, over time, improve our understanding of it. So, for example, with gravity, a while ago, Newton comes along, Isaac Newton, and says, I think I understand more of the characteristics of this gravity. And he tries to expand this construct. He tries to add to our construct that we're calling gravity. And he comes up with something called the law of universal gravitation. And he figures out some of the ways that gravity works in the universe. But it actually turns out that he wasn't exactly correct, and Einstein comes along later and revises the construct. And he says, oh, it doesn't have to do with the things that Newton thought it has to do with. It has to do with curvature of space-time. And he has this very sophisticated revision of the construct. And that is one of the things that you will see with constructs. Constructs in psychology are very much the same in that we know some of its characteristics, but we can't observe all of it. We don't understand exactly how it works, but we're continually trying to improve that understanding over time and revise it. So you will read in scientific journal articles, sometimes quite a lot of time is being spent debating, arguing, or making suggestions over what should be the correct way that we're thinking about a construct and how can we best add on to our understanding of it. We also take constructs and we say, okay, we know these things about them. We think the different parts of the construct are related in this particular way. That helps us explain stuff that we maybe couldn't explain before, or predict things that we couldn't predict. So we might take some aspect of Einstein's theory of gravitation and then use it to predict something out in the universe and then look to see if that thing actually happens. So constructs, even though they're hypothetical, we don't know if this is exactly how all these different things are related, and we don't know if this is exactly how things are working. We can use the construct to help us explain things and predict things. And then, depending on whether those explanations and predictions seem to hold true over time, we can revise the construct to make it better. So a construct is a variable, but it's a variable where we're saying we can't get at all aspects of it, at least not at the moment. So we're going to have to try to do our best to put together a good picture of this construct and revise it over time. But another thing you will often see is you'll see constructs defined as oops, that's the wrong color, as explanatory, meaning, like I was just saying, they're used to explain things. So we would say a construct is an explanatory variable that can't be directly observed. So why is a person acting the way they're acting? Well, because of their anxiety. Is anxiety something that we can directly observe? Well, not exactly, but there is this cluster of things that we can observe that all seem to be tied together in a certain way, and we call those anxiety. We call that cluster of characteristics that all seem to be related in some way anxiety, and that then allows us, our understanding of that construct allows us to then predict other things or explain other things. Why is that person acting the way they are? Well, because of an increased state of anxiety. So constructs are explanatory variables that cannot be directly measured.
Okay, so let's talk about different ways that you can measure construct validity. So the first way is face validity. So the content of the measure appears just on face value to reflect the construct being measured to a layperson. So for example, Sally thinks this test generally makes sense in its measurement of depression. There are no random questions or questions that don't belong. Another way is content validity. The content of the measure is linked to the universe of content that defines the construct. For example, a student wants to create a survey about depression and gets expert psychologists who specialize in depression to help her make it. Content validity is similar to face validity, but uses a more methodological approach, getting the experts involved in creating the measure, for example, because the content of the measure was linked to the universe of content that already defines the construct. So they got experts involved and they were able to decide and make the determination that this had content validity, the measure. Predictive validity is another way. This is scores on the measure predict behavior on a criterion measured at a future time. So for example, students who scored well on the ACT ended up doing well in college upon graduation. So this is something that admissions counselors look at when they're deciding whether they think that you're going to be successful at the institution or not before they admit you. Concurrent validity. So these are scores on the measure are related to a criterion measured at the same time concurrently. So for example, you are a second grade teacher and it's the end of a school year. You know your students pretty well now and are asked to classify them as introverted or extroverted. This is the first measure. The students now take a personality test to test them on their extroversion and introversion. This is the second measure. Afterwards, you compare measures by testing for correlation to see whether the students who you claimed as the teacher are outgoing indeed scored as outgoing on the personality test or not. So that's another way that you can measure construct validity is through concurrent validity, and that's using two measures that are being done at the same time. And then similar and dissimilar, so there's convergent is similar, discriminant is dissimilar. So convergent validity is scores on the measure are related to other measures of the same construct. So for example, student scores on the ACT should be similar to those on the SAT. So I realize that they're on different measurement scales, but there is a way where you can look at an ACT score and match that up to what an SAT score would be. But the idea is that these are similar exams and should be able to similarly provide information that shows that a student is going to be successful. So another way that you can show validity is to show convergent validity in your measures. And then also discriminant validity. So these are scores on the measure are not related to other measures that are theoretically different. So for example, students who score as shy on one test should score as forceful on another test because those are opposite ideas and are theoretically different. So these are different types of ways that you could show validity in your research. So these are some more examples of validity. It goes over face, content, predictive, concurrent, convergent, and discriminant. This is table 1 from your book, and so I welcome you to either pause the video and go through this now, or go through it in your own time in your book. And I can't have a lecture on reliability and validity without explaining this famous target visual. If you went to Google and you typed in reliability and validity and went to images, this image in many different forms would show up. So I need to give this example of what reliability and validity is just as a visual for you. So let's go back to that what we were talking about before. So you're writing a survey to measure a student's level of social introversion or extroversion. So that's your measure. Is you're decided that you're going to do a survey and you're going to make the survey. And this is what it's on. We're trying to measure social introversion or extroversion, which is our construct. So you already know who's extroverted and introverted in your class just by you knowing your students. This right here, this red target is extroversion. Extroversion can be hard to measure though, right? Because it's a construct and it's not directly measurable. So a really good survey that truly measures extroversion is in the red. Their participant scores are the black dots. So on the left, this is an example of what might happen. Your extroverted students score the same, but not in the right place. Thus, maybe a question on your survey was worded in a way that all extroverted people misinterpret it in the same way. So you can have reliable results, but not valid because they didn't score right here on the extroversion. In the middle, your extroverted students score all over the board and not in the right place. Thus, maybe students didn't understand your survey question at all. So this is something that's not valid and it's also not reliable. And then lastly, on the right, extroverted students score in the same place and in the right place. So your question was worded correctly and measures what you wanted it to measure. It was both valid and reliable. So reliability and validity is helpful because they help to reduce measurement error and make the observed score a better reflection of the true score. So they try to get rid of this measurement error as much as possible and make the observed score a reflection of the true score. So for homework, you have a quiz. Quiz part 1 covers reliability. The questions are on a PDF, and then submit answers via the answer sheet, which is in Word. Quiz part 2 covers validity. Review the questions on the PDF and then submit answers via the same answer sheet. So there's going to be two different PDFs, a part 1 PDF and a part 2 PDF, but just one answer sheet, and then upload that answer sheet. Also for your homework is book activity number 1, which is on page 117 of the book toward the bottom. If you need more help learning about reliability and validity, these are some YouTube videos that I found that I thought explained both of them well, but you're welcome to find some more on your own. I'm sure there are plenty out there, but I just wanted to provide you with some additional resources. Also, feel free to ask me, and I'm here to help. So thank you, and I hope you have a great week.